I can do it. Winner,
Okay,
winner.
perfect.
All right, so you hooligans can try this problem, and then we'll get started from there. We'll give you 2, 3 minutes, and then yeah.
Yeah, and you can look at my screen for the timer.
And May, do you know how to give me screen sharing privileges?
Yeah, I thought I just did that. It says
Oh, did you
when I
just
click
do
on your name,
that?
it says remove permissions to record local files. So you
No,
should have that
there
permission.
should be one for screen sharing too.
Hmm. Uh,
If you make me host again, that would be fine.
okay. How do I do that?
Okay, so click on the three dots again
Yeah,
and then see if there's one that says make host.
there is not one
There is
that says
not. What
that.
are the
Let me
options?
wait 1 second. It says like mute, stop video chat, and rename.
15 seconds.
I'm so clueless. 1 second.
Okay, wait. I got you. Go to the bottom of the screen where it says settings. Do you see at the bottom there's like a settings bar
Second minute.
in like the area where the breakout
Here,
rooms?
wait. Let's move to the statistics room and do this.
Okay, sorry. I feel so bad. I hope you guys are having fun.
And just a reminder, normally for cipherings you do get 3 minutes, but today we're only giving 2 for sake of time. So once we hit the end of the second minute, Ritvik is going to present his solution.
You don't have to DM me answers. We will just we'll ask people if they got an answer, and then we'll go over it from there.
Third minute.
Oh, oops, I think we forgot to stop at the end of the second minute.
Oh, okay, got it. Yeah. All right. So let's start with, this is a time-based question, so let's start with plotting out the time. We're told that Michael and Ryan begin working at 1 p.m. All right, so at 1 p.m., we'll say a scale from 0 to 1 of the house, right? 0 is the percentage of the house that's completed, 1 meaning that the entire house would have been painted at this point. We're given the rates for the individual members. Michael can paint a fence in 4 hours, which means his contribution in a single hour. Because remember, anytime we do rate problems like this, think back to the equation D equals RT, where distance in the sense is a metaphorical allusion to how much of the house is painted in a sense, or how much they covered. So since distance is always constant for them and time is always constant, then the rate is what's changing, obviously. So we measure everything in a unit hour. So Michael paints at a contribution of 1/4 a fence in an hour. Ryan paints 1/12, and Evan paints 1/3. So Michael and Ryan begin working at 1 p.m. and they work up until 3 before another member joins. So at 3 p.m., we need to check their contribution. Okay, so they've worked 2 hours, and if they're working together, that means their rates can be additive. Remember, it's not the same as adding their time, because that would contradict that time elapses at the same rate, but the rates are additive because as one person is working on one part of the house, the other one can work somewhere behind or whatever. But the point is that we can add the rates together. So by adding Michael and Ryan's rate, we have 1/4 plus 1/12. This becomes a common denominator of 12, which is 3 plus 1, which is 4, which is 1/3, meaning that both of them combining their brain cells can paint 1/3 of a fence. And again, the same unit time of 1 hour. Now, what do you do? They've went for 2 hours, they work, so they've painted 2/3 of the fence up until 3 p.m. But now we need to calculate the rest of the contribution that is occurring. So Evan doesn't begin working till 3 p.m. Okay, so we're now told that Evan's rate is also 1/3 on top of that. So what that means is they need to do 1/3 plus 1/3, which is now 2/3, meaning that all three of them combined paid 2/3 of offenses in and out. Right? And so finally, the question we haven't gotten here yet, they need to complete painting 2 fences. So 2 fences is the total amount minus the 2/3 that Michael and Ryan worked together to make is total of 4/3 fence left. And from this point on, we have Evan joining them as well, and we've already calculated their combined work rate, which is 2/3. So therefore, with the same analogy of D equals RT, they have 4/3 left to paint, 4/3 fences left to paint. They are working at a rate of 2/3, and they calculate the time. Obviously, this is just T equals 2. But remember, we're starting from the point of 3 p.m., not just 1 p.m., because 1 p.m. we've already calculated their contribution. They've already done 2/3. We're now starting our timeline from 3 p.m. So 3 p.m. plus 2 elapses to 5 p.m. And so in the ciphering, I think 5 p.m., 5 like this would be a sufficient answer. Anyone have any questions?
All right, awesome. So we'll give you guys the timer to start question 2. And I just realized we never gave you guys the test, did we? So the time that we just gave you was pretty useless. So let me go ahead and drop the test in. Okay, so
I think it was still valid because I had it screen shared while the timer was running.
okay,
so
perfect.
Now they have it. So
yes, okay, so yes, because I have the timer, I can't show the problem on mine. So I'll let you guys a second to download that. I'll just give you the full 3 minutes to account for anyone that's trying to do this stuff and pull up the test. So start question 2. And if you get any kind of answer or idea on how you want to solve this one, you can send it to me in chat through a DM or just send it to everyone.
yeah, and don't be afraid to, before we start going with the solution, say it out loud to the class so we can all either correct you or tell you that's the right idea.
No shame in getting it wrong and lots of glory in getting it right.
15 seconds.
Okay, someone just said they do not have a link to the test. You should be able to see the file that I sent to everyone in chat, just, I guess, the most recent message for everyone. Okay, looks like people
Second minute.
didn't get it. Do you guys not see the test in the chat? No. Okay, that's weird. I did send it in chat. Oh, Rob sees it. All right, let me try sending it again.
Yeah, I can see it. Maybe just a delay.
Okay, I did send the test again. And you know, I can also pull it up.
Fifteen seconds.
Okay, people still don't see it. Okay, looks like Ritvik's got it.
Third minute.
Oh, I think that's the wrong question. Yeah, that's question 3. There we go. This question.
15 seconds. Time.
All right, a little less than 3 minutes because of technical difficulties, which always try to destroy us, but that's all right. Let's just see it right here. Does anyone have any ideas on how they got started or any answers? You can send it in chat, you can DM it to me. If not, that's okay. Rivik, thanks for sharing. I think we can get rid of that so they could see me now. Thank you. Okay, so no answers or ideas yet, but let's get started. So basically this wants us to find the determinant of a 4x4 matrix, and the way that you do that is by choosing either a row or a column and taking each one and then multiplying it by a corresponding 3x3 matrix. So basically, let's say we chose this top bar, the top row. We would take 5 times, and this would be the determinant. You're going to cancel out this row and column, and that'd be 5 times the determinant of 0, 1, 0, 5, 1, 0, 1, 3, negative 1, 8, 4. All right, and then you would go to the next one. So next is a 2. But what we have to do is this really fancy thing that's not really that fancy. We're just putting in a bunch of negatives. And starting from here, it's going to be plus, minus, just going all the way down and across. And then plus, minus, plus, minus, plus, minus, plus, minus, plus. So you do have to make these like little pluses and minuses when you're solving for your determinant. That's something that's really important to keep in mind, because there's usually like false answers where you don't subtract it and you add it instead, because this does show up pretty often. So let's do just that. And we want to choose the best row, because although it is like usually the same amount of work, you can see that we have these zeros here. So if we were to choose this column, well, instead of having to do it 4 times, we only have to do it twice, because the zeros would mean that the 3x3 matrices that we multiply by just become 0 immediately. So again, let's put back our pluses and minuses, but just starting here. Oh, make the question bigger. Sure thing. Okay. Can you paste it in the lower corner, the zoom icon? Okay, how about, is it better on this side? Okay, hopefully this is better for some people. So let's make the pluses and minuses here. So plus, minus, and then we can just go straight down, minus, plus, minus, plus. So it's going to be negative 2 times the determinant of our 3x3 matrix, which we're going to cut out this one, and that'll leave us with 1, negative 2, 2, 5, 1, 8, 1, 3, 4. So these like symbols here just mean the determinant. And then we're going to have to add our plus minus 1 here. So plus negative 1 times, and then we're going to cross out these. The determinant 5, 1, negative 2, 8, 5, 1, negative 3, 1, 3. So a lot easier to do than just looking at this, but now we have to actually find the determinants of our 3x3 matrices. And we could do the exact same thing that we did here to get like these small 3x3s, or we could just do my preferred method, which is multiplying the diagonals and then subtracting the opposite diagonals. So it's going to be 1 times 4, which is this first diagonal. Here, let me change color actually. Okay, 1 times 4, plus, and now we're going to go this diagonal, so 5, 3, 2, plus 5 times 3 times 2, plus our last diagonal, 1 times negative 2 times 8, and we're going to subtract the sum of the opposite diagonals. So minus, and now we get this diagonal, 1, 1, 2. So 1 times 2. We're going to add the next diagonal, 5 times negative 2 times 4, and our last diagonal of 1 times 3 times 8. So another color again. This is 4 plus 30 minus 16 minus 2 minus 40 plus 24, or in other words, 18 minus negative 14, which is going to give us 32. Okay, do we have any questions on how I found that this determinant was 32? I don't see any questions, so I'll erase all of this. If only I had a better eraser. All right, so that's negative 2 times negative 32. Now we have to find the same thing with this determinant. Switch colors again. So 5 times 3 plus, we're going for our other diagonal, 8 times 1 times negative 2 plus our last diagonal, negative 3 times 1 times 1. And we're going to subtract our opposing diagonals. Negative 2 times 5 times negative 3 plus 1 times 5. And our last diagonal, 8 times 1 times 3. So, some more work. That's 75 minus 16 minus 3 minus 30 plus 5 plus 24. So this is going to be 56 minus 59, which is equal to negative 3. And if you see any like math errors, let me know. Arithmetic is pretty hard. So that means that this whole thing right here is all negative 3. Does it matter which diagonal you are subtracting from? Great question. So what we do is when we have a 3 by 3 matrix like this, we're going to add all the white diagonals, and then we subtract all the yellow ones. So if you can see on the picture there, the white ones get multiplied and added, the yellow ones get multiplied and subtracted. So now we can just do our very last math. Negative 1 times negative 3 plus negative 2 times negative 32. That's 64 plus 3 for an answer of 67. So the determinant of this 4 by 4 matrix is going to be 67. Does anyone have any questions? All right, if we don't have any questions, I'll put the timer back on and let Ritvik take it away.
All right, you guys can begin question 3 now.
Fifteen seconds. Second minute. Fifteen seconds. Third minute. "15 seconds. Time.
All right. So anyone have any ideas on how to start? What does our initial configuration look like? All right. So we're gonna say home is down here. Because he says Charity's on her way home, which is 5 miles south and 3 miles east of her current location. So it looks something like this. This is 5 miles south and 3 miles east. It should be like this. So 3 miles east looks like that. And we're told a river runs 1 mile east from our house, something like that. All right. And so then she needs to stop at the river and also go home, and we want the minimum distance. All right. So what I want to consider is that if I reflect this line that connects, assuming she took this straight path and she made a right angle at this turn here when exactly she hit 3 miles east, what we do is I reflect this line over here. So obviously this new center for H here is going to be over here, and there's now one segment left. I read that wrong. That is 5 miles, it is west. I am an idiot. Go figure. I get the eraser. All right. So something like this. This is the other east. And so the river is right here. This has a distance of 1. And so, as I said, consider the same reflection about here. That means we're also at a distance from 1 here. We'll call this H prime. Consider it a mirror image of itself, because again, distance is preserved when we do reflections. So we can consider this segment is still 5 here. And this is still 3. So we have labeled this as C prime and H prime. And then we're asked to find the minimum distance that she needs to travel, to get back to her house. So of course, the easiest distance is going to be straight across. Is always going to be a straight line when we're connecting 2 points. So in this case, it's going to look like that. Now, of course, this line won't actually occur when we're doing it, because what it's going to actually happen in reality, she's going to hit the river and go back. But again, distance is preserved when we do rotations. That's the concept in what we call in geometry affine spaces, meaning that reflections and rotations preserve the symmetry of the diagram that we're looking at. So this straight line is in fact the same distance as if I went to the river and went back to the house, at least minimizing it. So we know that this is 1 plus 1 plus 3, which means it has a base of 5. And we know this is a right angle as well. So this also has a base of 5. So conveniently enough, we have a base of 5 here, a height of 5 here, and we want the straight line distance between these 2 points. This is just either your special triangles, 45, 45, 90, or your just do Pythagorean theorem. In any case, you get the result of 5 square root of 2. The important concept here is that while it may have been much more difficult to find the configuration where she has to go to the river and go back to her house only in one side, by doing the reflection, we showed that there is still a straight line distance that still preserves the amount of distance she would actually travel had she only gone on one side, as I showed illustrated right here. But it still allows us to do the triangle, this 5 by 5 triangle, which we would have never found earlier. For those who are more particularly curious about why this works, consider like you could draw every triangle here and eventually you're going to find one that has a right angle. And so by actually calculating the distance using similar triangles, you're going to get this is also 5 root 2. But this reflection concept is important for a lot of geometry. So that's our final answer. Any questions? Fantastic. All right.
All right, awesome. So I'm gonna pull up the next question. I think I fixed our little issue. Wait for it. There we go. Okay. So can everyone see the question and the time?
I could see it, and that's all that matters.
Yes, you are all that matters. Okay, so let's get this going. And while this question's going, I want to make sure everyone is still with us. So can anyone that's still here send what school they're at and their grade either in chat to everyone or to me or Ritvik, just to make sure you guys are still paying attention.
Wait, what are we doing again?
This is going to be question 4, so you can do this for the next 30 minutes. But while we're doing this, can you send me what grade you're in and the school that you're at, just so we know that you're paying attention? Just a really basic question. It's not like anything.
To who?
Everyone, or to me or Ritvik. I see lots of people are doing it. Awesome. Ooh, someone from 6th grade.
Fifteen seconds.
All right, lots of people still with us. That's awesome. And thanks for sending me your school and grade.
Second minute.
And Ritvik wants to flex his grade 13 status at Caltech. That's how you know that you're learning from a master.
Yeah, it's the grade 13 part, the university is unimportant.
Yeah, that doesn't matter. All right, yes, and remember that once you get an answer, you can send it to me also, and we'll see if you guys are right. As another reminder, no shame in
15
being
seconds.
wrong, lots of glory in being right.
Third minute.
Okay, so I'm actually just going to stop us right here, just for sake of time. Let me put myself back. There we go, the problem nice and big on my screen. So let's get started. I see lots of different answers. It's really great that you guys are getting it on your own and trying it. So let's read it together. Patricia and Gabriella are taking turns playing heads or tails. First, Patricia flips the coin and calls heads or tails while the coin is in the air. If she is correct, she wins, but if she's wrong, Gabriella will flip the coin, and the game continues until someone gets the head, or until they correctly predict the coin flip. What is the probability that Gabriella wins the game, given that they are playing with a fair coin? All right. So the most important thing to realize here is that every turn they get, well, the probability of getting the answer right on that turn is 1/2. So let's try and make a little sequence. So the first time that they play, there's a 1/2 chance, and then our winner here would be Patricia. So let's write that with a P. And then on the second flip, well, Gabriella has a 1/2 chance of getting it right. But something you need to notice first is that this won't always happen. There's a 1/2 chance that Patricia gets it wrong, and if Patricia gets it wrong, then in that case, Gabriella can get it right. So then that means that there's a 1/2 times a 1/2 chance of Gabriella getting it right. Okay, so let's go on for our third flip. Well, there's a 1/2 chance that Patricia guesses it right then. But again, it's not just 1/2, right? So there's a 1/2 chance that Patricia gets it wrong on the first time, and then a 1/2 chance that Gabriella gets it wrong on the second try. So we have to multiply this by 1/2 times 1/2, and that would be the probability of Patricia winning. So if you notice that every time we do this, we're just multiplying by 1/2, and we want the probability that Gabriella will win. So the first time we have is 1/4. And now if we go to our fourth flip, well, it's going to be 1/2 times 1/2 times 1/2 times 1/2. That's Gabriella, or 1/16. And I'm not going to go out through a bunch of terms because we don't have time for that. But basically what you'll notice is that the probability of Gabriella getting it on the second flip is 1/4. The probability on the fourth flip is 1/16, so we're going to add them. And then on the sixth flip, well, that's going to be 1/64, and every time you're going to be multiplying by 1/4. So this just means that we have a geometric sequence. I'm going to erase all this. The answer is just going to be the sum of a geometric sequence, where we're multiplying by 1/4 every time. So let's write this out fun. So the sum from I equals 1 to infinity of 1/4, 1/4 to the I is basically, if we write out our entire sequence, 1/256, blah, 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 we can just write it like this. And does anyone know how to find the sum of an infinite geometric series? Does anyone know? Okay, a over 1 minus r. Awesome. So yes, the sum is going to be, I like how Nishini wrote it, was a sub 1 over 1 minus r, and a sub 1 is going to be our first term, and r is going to be our common ratio. So it's 1/4 divided by 1 minus, well, every time you notice we're multiplying by 1/4, right? So 1 minus 1/4, that's 1/4 over 3/4, or 1/3. So that's a really great way of doing it. And it's good that you guys know this formula, but does anyone know how you can actually prove the formula? This is a little tangent not related to the problem, if you do know the formula already. Does anyone know how to do it? No? Okay. So let's just say that we have, do this really quickly. So a sub 1, and then plus a sub 1 times r, plus a sub 1 times r squared, plus a sub 1 r cubed, dot, dot, dot. And we're going to say that this is the series. Okay, so we know that S is going to be equal to a sub 1 over 1 minus r, but let's try and prove that. So the first thing that we want to do is multiply S by r. So S times r is going to be equal to a sub 1 times r plus a sub 1 times r squared plus a sub 1 times r cubed, dot, dot, dot. Now what we're going to do is subtract SR from S. So S minus S times R, well, let's look at this. This minus this, that cancels, that cancels, that cancels, and it just leaves you with a sub 1. And now we want to just get S isolated. So S times 1 minus R is equal to a sub 1. So S is equal to a sub 1 over 1 minus R. So the formula that most of you guys just memorized, and this is just a nice little proof for it. Any questions? All right, I don't see any questions. I saw lots of people getting the right answer, which is fantastic. So we'll put it back on the timer so you guys can try solving problem 5.
15 seconds. Second minute.
I'm gonna go to the bathroom.
Thanks for letting us know.
Wait, what?
15 seconds.
Sorry, I was unmuted. I didn't notice, so sorry.
You're all good.
Third minute. Fifteen seconds. Time.
All right. So let us begin. So immediately, whenever I see problems like this, where I have like 2 or 3 different categories, I know it's going to be something, if you're familiar with the term, it'll be great. Otherwise, we call it Principle of Inclusion Exclusion, or PIE, apropos acronym, PIE. So it stands for Principle, Inclusion, Exclusion. Now, I'm going to write it out numerically as well as graphically, so you have a better understanding of what this principle actually means. So there are 100 music critics asked to give their opinion on Young Thug's song Lifestyle. Personally, I think it's a banger, even though I never heard it. So I have to say it's fire, but apparently I'm not in the question. But 30 critics say that it is fire, 35 say it is dope, and 40 say it is dank. So, and we read on, it tells us that 10 say it was fire and dope only, 5 say it was dope and dank only, et cetera, et cetera. It gives us categories. So what we do is we're going to draw a Venn diagram. Look something like this. At the top here, we're going to here put fire, FI, dank, DA, dope, DO. Now, why am I doing this? Well, because I'm told that there are intersections between each of the groups of people that I see, or all of the people who said it was dope, dank, fire. And so my goal is to find how many did not think the song was any of that. Okay. So let's start filling with information we do know. There are a total of 100 music critics. So whatever we add, subtract, all that stuff that we're going to do, it has to add to 100 because we can't exceed the total number of people. We're told that 30 critics say that it is fire. So that means that all the sections in this circle where I just put my little dots have to add to 30. So that's 30. 35 said it was dope. And 40 said it was dank. But the problem is that these intersections where I I point out right here, the intersections that I'm pointing out right here are going to be double counted. So the problem is that I need to account for that somehow. So how do I do that? Well, I end up subtracting this inner part out. So I need to find the people who find it dank and fire, because again, this is being counted twice. See how there are 2 dots here? Because when I wanted to count the fire section and the dank section, it ended up being counted twice. So how do I remove that? I subtract out the people who thought it was dank and fire. That way I only count each people who voted once. So we're told that fire and dank, 5 people thought it was fire and dank. And similarly for here, there are 2 dots being this over counting. People who thought it was dank and dope say it's another 5. And the people who thought it was fire and dope is another 10. But again, the issue is that when I ended up counting all of these, the people who thought only it was 2 of the adjectives, there are the people who thought all 3 adjectives applied to the song. And so that's, again, undercounting. I keep on subtracting that amount out. So yet again, I add, which is my desired value, X. X is the number of people who thought it was fire and dope and dank. And again, I only have one variable here, so I can just solve directly. So 30 plus 35 is 65. 65 plus 40 is 105. And then 5 minus 5 is 10. 10 minus 10 is 20. So that means we're having 105 minus 20, which is 80. And then we're told 100 equals 80 plus X, which means that X equals 20. Right? So that means there are 20 people who like this in total. And now we have to work backwards. So I showed you how to do it numerically, which is where you subtract the overcounted parts and add the undercounted parts. So now we have to work with the information given. We're told that 10 people thought it was fire and dope, which is this people right here. 5 said it was dope and dank, which is here. And 5 said it was dope and dank here. And now finally we can fill in the people who only thought it was fire, only dank, or only dope. People who thought it was fire is 20. 20 plus 10 plus, I think I did math wrong. There should not be this much of an intersection. One second. Math moment. I see my issue. They already told us that 3 people found it fire and dank. I see. I was overcounting or undercounting rather. Man, my ability to read is just astounding today. Okay. So let's start this over again. They actually gave us, this is a bad example, not in addition to my inability to do arithmetic, but because they gave you all the information you needed. So it's kind of irrelevant for me to draw this. But what I'll do now is I'll illustrate it to you graphically. Circle, circle. Oh, God. Let me draw that again. 1, 2, 3. Okay, well, close enough. We're told that the intersection is 3 here, and we're going to fill in our perspective here. 10 people say it was fire and dope, which is this part right here, 10. These other ones are 5. And now we finally subtract. 30 say it was fire, but that includes that entire circle. So 30 minus 5 minus 3 minus 10 is going to be 18. So this is 12 here. And then above here, 40 said it was dank. So 40 minus 5 minus 3 minus 5 is negative 13. So 27 here. And then finally, 35 said it was dope, and we subtract their intersection. 10 plus 3 is 13. 13 plus 5 is 18. That means 17 here. Now, we have all their individual parts. What does this mean, again, in physical context? 12 people only thought it was fire, nothing else. 70 people only thought it was dope. 27 people only thought it was dank, no other adjective. And now they want the people who did not think it was any of them at all. So all we have to do is just add up every one of these individual sections here. So we have that 12 plus 27 plus 17, that is 39, plus 17 is 56. Now add up the inner parts, 5 plus 5 plus 10 is 20, which is 76, plus 3 is 79. That means 79 people thought it was at least one of the adjectives. But we said that a total is 100, which means the other people, because it's you either have an opinion or you don't. So therefore it's 100 minus 79, which is 21 total. That means there are 21 people who did not think it was fire, dope, or anything of the amount. So, yes, I got a bunch of DMs about that. Okay, yeah, so I did not read, and when I said only here, I forgo that part of the words, but yes. In essence, what we did is we calculated each of the individual portions that everyone was attending, or their adjectives. And then once we have found out the people who at least had one adjective to describe the song, we did 100 minus 79, and that equals the 21. Yeah, I think it's quite a bit. I think I can take it from here, Jesse.
Okay, actually, I think I have time to do one more quick one.
Okay.
So I'll just jump in. Okay, unfortunately I can't give you guys time to just like think about this one. So we'll just go through it together. And I'm gonna go over some like formula names, I'll write them down now. That is gonna be really helpful for you to know in just theta in general. So this is something called Vieta's formulas. So definitely look into those. And basically what it says is that the sum of the roots. So in this case, let's say that our roots are, I don't want to use x and y. Let's just say that our roots are d and e. So again, the roots of an equation just means like the things that you plug into the quadratic to get it equal to 0. So if our roots are d and e of this polynomial, then Vieta says that d plus e is going to be equal to negative b over a, and d times e is going to be equal to c over a. So this is some really useful things that will help you solve things faster, so you should definitely check them out. And basically we're saying if we want to find the sum of the reciprocals of the roots, or in other words, 1 over d plus 1 over e, well, let's look at this. So this is the same as e plus d over e times d. So in other words, this is going to be negative b over a over c over a, which is the same thing as negative b over c. Okay, so immediately, that means we don't have to find the sum of the factors of 100. We just need to get the sum of the cubes of the first 5 positive integers and the sum of the row of the Pascal's triangle with 8 terms. All right, so let's do b first, and there is a formula to do this. And let's just say, I'm going to erase this part of Vieta's, is that the sum of cubes, so it's the sum of the first n cubes, is n times n plus 1 all over 2, and then you square it. So for finding the first 5 ones, well, that's 5 times 6 over 2 squared, which is equal to 15 squared, which is 225. So let's write this here. B is 225. And now we have to find the sum of the row of Pascal's triangle with 8 terms. So for anyone who doesn't know, this is also something that's really worth looking into. Let me erase this. Okay. So for anyone who doesn't know, Pascal's triangle is 1, 1, 1. And then from here on, you just kind of add. So 1 plus 1 is 2, there's 1, 1 plus 3, 3, 1, 1, 4, 6, 4, 1. Notice that each of these numbers is just the sum of this plus this. And this triangle has some really cool combinatorial properties. So I definitely I'm going to tell you to look this up a lot because it's really cool. All right, so you could keep writing it out, or you could just say that the sum of the numbers on the nth row of Pascal's triangle is actually going to be equal to 2 to the n minus 1. So notice, right, this is the 0th row. So that's 2 to the 0 is 1, 2 to the 1 is 2, 2 to the 3 is 4, right? And you can see that this holds up throughout. So if we're looking for the 8th row, then it's going to be 2 to the 7th. Okay. So what's 2 to the 7th? That's 128. So just a quick and easy way to find that C is equal to 128. And remember that we said our answer is just going to be negative b over c. So our final answer is going to be negative 225 over 128. So unfortunately, I do have to go right now, but Ritvik is going to stay and keep going through some problems. You should stay and listen to Ritvik because, as we discussed, he's grade 13, so he's a legend. He's the Obama of FAMAT. Very cool person. Stay and listen. And if you have any questions, he'll be there to help. But for now, bye everyone.